G'day chemistry students, and welcome to the first video for module 2. Now we're beginning to enter this second module, Introduction to Quantitative Chemistry, and in this module in particular, what we're going to be focusing on is, rather than a lot of the big concepts that underpin chemistry, a lot of the things that we saw in the first module, here we're going to be looking at a lot of the techniques and skills and calculations and ways to talk about and understand chemistry at a quantitative level, a way that's measured. As scientists, we are measurers. We don't just observe things and explain phenomena by what we see, but also by what we measure. And a lot of the things that we've already talked about to begin with, we've talked about qualitatively, we've talked about them as ideas or concepts, but they've been proved by quantitative means. And so what we'll be looking at is how chemists quantify the world in this topic. Now, to do that, what we'll be doing first is looking at some gravimetric analysis techniques. Now, you may have done some of that already in the separating mixtures practicals that you would have done in module 1, but I wanted to go through an actual practical, a simple reaction, and show you some of those gravimetric techniques, because when we're in the lab, one of the ways in which we can actually measure different substances and how much they are and all that sort of stuff is by mass. So gravimetric is talking about the force of gravity, metric is talking about measurement. So measurement by gravity, in other words, we are measuring weight, and we convert weight into mass because we know that the gravity on our Earth is constant. Now, in this practical, what we're aiming to do is determine if there are any mass changes in a precipitation reaction when 50 mils of calcium nitrate is added to 50 mils of sodium carbonate. Now, the reaction over here highlights what's going to happen. We start with calcium nitrate and we start with sodium carbonate. And when those ions in solutions, because they are both aqueous, as our brackets say, when those ions come together, the calcium and the carbonate ions will form a solid, and that will be the precipitate, while the sodium and the nitrate ions will remain aqueous. Now, the idea here is this precipitation reaction. Look, it may be something that you have already seen, say, in year 10, maybe even in year 9. But this precipitation reaction is something that we'll look at in a lot more depth as a reaction itself in module 3. For now, we're using the reaction as a way or a means to measure mass. And with that, let's get to it. So first off, what we're going to be doing before I actually show you the reaction that I undertook in the lab, I want to talk about how to weigh liquids by mass. So the best way to do so is to weigh the container that you're about to put the liquid in, transfer the liquid into the container that you've just weighed, and weigh the total mass. Excuse the typo, but we're going to weigh the total mass of the container and the liquid. We're then going to calculate the mass of the liquid by taking the difference of the total mass and the mass of the container. In other words, if I had a sample of water and I wanted to measure how heavy it was, I could take the mass of the beaker, let's say it was 25 grams. The mass of the beaker and the water together was 70. Well, the difference between the two, 100 minus 25, is going to be 75 grams. Everything that's remaining is going to be the water that we have added. And this technique is really effective, mostly because say in an active lab where there aren't many balances, you can't really tear the balance and do a reaction and come back half an hour later expecting that the balance is going to be ready for you to weigh. So if you know what the mass of the container is at all times, you can always just do that conversion yourself. I will show you how to tear our balances in the video, but it's not a technique that I would recommend doing. From the day to day, I guess. If you know that you're going to be able to take advantage of that tear function, then by all means do so. But in most cases, especially when we're doing labs here at school, those balances are active balances and are getting used by everybody. So doing a full write-up like this, where we take the mass of the container and the substance, and then calculating the mass of the substance at the end, can be really, really, really important, and make sure that you don't get halfway through a practical and have completely botched all of your masses for the rest of the experiment. But anyway, let's go have a look at this reaction. So I have my setup. I have my two solutions and some beakers ready to go. Also got a couple of measuring cylinders. The first thing that I'm going to be doing is getting my calcium nitrate and getting that ready to pour. So I'm going to be measuring out 50 mils with a measuring cylinder. Doing that now. Notice as well that I'm keeping my eye level even with the graduation that I'm looking at on the measuring cylinder. That's to reduce parallax error for the meniscus. Now what I'm going to do before I put the liquid in is I'm going to take the mass of the beaker first. So that's 109.89 grams there. I constructed some tables up on the board, which I'll be filling in as we go. So the mass of beaker 1, I'm going to write that down now. What I'm then going to do is take my my measuring cylinder and pour the 50 mils of calcium nitrate into the beaker. And with one hand, try to transfer that over. So I have 195.83 grams measured there. I'm now going to take that to the table. Writing that in now. Now I've written down 8.3, and that's all recorded. I can calculate calcium nitrate mass later, and I'll do that at the end. So I can just take the difference of the two. What I've noticed though when I come back is that it says 165.82. So I actually did a quick adjustment. That can happen. Sometimes balances can settle out, and you might have to make an adjustment there. Usually it's recommended that you leave the balances to adjust for a minute before you actually take a reading. Now we're going to grab our sodium carbonate and get that ready to pour. So we want 50 mils of this one as well. With one hand, I'm going to try and get this cap off. It had a bit of a safety lock on it. One-handed is a little bit difficult. Then going to pour my 50 mils into my measuring cylinder. Again, notice that I've put myself and the camera about level with the 50 mil mark. Just falling a little bit short. Give me a sec. So I think it was a little bit over, but we're not too worried about the accuracy of our volume measurements. The mass is much more important because we are doing gravimetric analysis. So as long as we have an approximate volume, we're completely fine. Now what I'm going to be doing first, again, is taking the mass of the beaker. So that looks to be 86.59 grams. Then I'm going to put that into my table. Again, I've looked back and found that it's 5.8. We're then going to take our liquid, pour it into the beaker, and take the combined mass of the beaker and the liquid, the sodium carbonate. That is 138.18 grams. We're then going to go to the board, put that in our table. I've actually done a double check. It's still 1.8, so you did see me pause there. What we're then going to do is combine the two beakers together. So I'm taking the mass of the beaker where the two beakers of liquid are going to be poured into. Record that. Had to double check, it's gone down to 20 instead of 2.1. Once we've got the mass, we can then take the beaker and combine the two solutions. So I believe that was the carbonate first, calcium nitrate to follow. What we'll see is the formation of a white solid precipitate. But at this point, all the contents of both solutions are now in the beaker. We can then take this mass and in a moment, we'll take that mass, 213.56, and put it in our table. So what we have now are our results, all complete. You'll notice that I've taken the differences of the calcium nitrate, sodium carbonate, and the sum of the two solutions, or the total of the two solutions, in all of our tables. All I've had to do is take the mass of the beaker and the solution, and taken away the mass of the beaker to find out the mass of the solution. I've then done the same for beaker 2 and sodium carbonate, as well as beaker 3 and the two solutions. Now you'll notice that the mass of the calcium nitrate and sodium carbonate adds up to 107.53 grams, whereas where we have 107.37 grams measured at the end, there is a slight difference in mass, about 0.16 grams. And this exists because we may have lost some mass through our pouring techniques. As we were moving along, some of that mass may have been left over in some of the beakers, and that's something that we should be accounting for as a source of error. Now what I want to show you at the end here is that we can also tear the beaker, and this is when we don't have to walk away from our balance and we're about to put the beaker down, take it off, put a substance in,
and measure its mass immediately. Now you'll notice that I pressed the yellow tare button and that set the balance to 0 with the beaker on there. It even says that there is a negative 846.48 grams sitting there. I've transferred a mass over and we can figure out how much mass this has now. Putting it back on, it's already taken the mass of the beaker into the account, and what we should get is a reading at the end that just shows the mass of the liquid. There it says 104.90 grams. This is less than the original mass that we got before. Some of that was left over, as we saw, as residue in the beaker.
Thank you very much. Now, in the next video, we're going to be looking at stoichiometry and balancing chemical equations, the idea that reactions occur in whole number ratios, and that we can use that concept to actually write out equations that tell us the amount of each substance that is reacting. But until then, have a good one.